Today we would like to discuss about the case study of the application of PLC and SCADA system in sewage treatment industry, which is IWK Sdn. I would like to introduce our group member, Kishan, which is our leader, Nicholas Ho, Chen Yan Ling is me, and Dan Long and Sam Suhian. Due to the insufficiency of water resources in the world, communities are forced to develop wastewater and also sewage treatment plants to produce clean water. In Malaysia, the largest sewage treatment plant is IWK Consortium IWK treatment plant. In IWK, sewage treatment process can be divided into 4 stages. The first stage is preliminary treatment, which is used to measure the water flow and also remove the oil and grease. Followed by is primary treatment. In primary treatment, sedimentation is carried out to remove the suspended solid. For the secondary treatment, biofiltration is also carried out to remove the biodegradable organic solid. The last stage is tertiary treatment. In tertiary treatment, filtration and disinfection are involved to remove the nutrition and also pathogens. To keep the process running within specific limit and also to ensure the quality and safety in the process control is installed in the plant. One of the process control system is programmable logic controller, PLC. PLC is a solid state device. It is used to control the output of the process through ladder diagrams, and also it provides the analog and digital inputs and outputs. The other process control system is supervisory control and data acquisition system, SCADA. SCADA is a software. It provides the data acquisition, logging, and control the plant variable. In SCADA system, inputs and outputs are presented in image. The automation of the process can be achieved by combining PLC and SCADA system. Now I would like to pass to Nicholas.
Good morning. Now I would like to introduce more about the opportunities and challenges of the implementation of PLC and SCADA in IWK Consortium Sdn. The advantage mainly focus on the access of the movement of process information between the plant floor, supervisory, and enterprise level systems. So in IWK, a host computer, a PLC, is connected with a few of instruments and transmission. Real-time process variables and state variables are displayed through this software integrator. As you can see from this slide, the flow rate of each particular streams and also the dissolved biochemical oxygen demand are displayed through this system. So for process engineers, they can actually do programming and data configuration through online. The implementation of PLC and SCADA system can actually help to reduce the training costs and also the support time. The current running step delay, and jump step of the water treatment process and also the instrument parameters can be easily modified. The system actually replaces the plant with identical graphical blocks. So every information of an unit operation or grouping informations are performed through a reliable interface. More importantly, with flexible control and openness. The focus will be on the integrated solutions to support this industry with a minimized human resources and energy, while maximizing the security of supply. As extracted from IWK Consortium Sustainability Report 2013, as you can see, the company actually spent 5.29 million ringgit on the training costs in the year of 2012 and 2013. So with the implementation of PLC and SCADA, this amount can actually be reduced. At the same time, provide a promising result, which is to maintain the efficiency of water treatment factory. Besides that, PLC and SCADA system can actually generate automatic signals and alarm system. So in the case of failure, in this case, for a real-life example in IWK, when the pH values in periodic water output does not meet the demand or exceed the limit, the system will generate automatic signals, which is to analog the quantity and alarm. So for recovery processes such as breakout operations and also automatic exit or soda feeding will be proceeded next. As you can see, extracted from the same report as well, the PLC will, in this part, to add or decrease the chemical components in each stream. What are the challenges? This installation of PLC costs more than SCADA system. PLC system requires a plentiful of work in connecting wires. So there are always difficulties to change or replace any damages. If there is an error occurs, engineers find it hard to find the root cause of the problem because PLC system consists of a huge network of codings. Skillful workforces are required, such as trial and errors for troubleshooting. Last but not least, the hold-up time for PLC is more indefinite and usually longer than SCADA system.
On this side is actually talking about the suggestions on the improvement where to able to remove the oil sludge. So what this method is about is actually about the biodegradations where with the aid of bacteria to break down the oil sludge. So as you can see on the slide, there's a green box. This is actually referred to composter, and inside the composter contains oil, sewage, sludge, as well as food. So this composter is able to turn around so that the mixing of sludge can be mixed and the food can be mixed evenly. As you can see, there's an arrow indicate that actually able to turn. So on the surface of the composter, there should having some holes on the composter. This is because the holes are able to allow the aeration effect. With this aeration effect, the bacteria are able to break down the sludge to form a material called compost. And this compost is able to enrich the quality of the soil where it can be act as the fertilizer. So why we use this method? Because this method is actually environmental friendly, economical. If you base on other methods such as using machineries or chemical solutions like centrifuge machine, it will actually cost very high. Hence, this is actually one of the methods can be used to treat the oil sludge. I will pass on to Kishan.
Okay, now I'll talk on a discussion based on a certain case study. This case study is about an experimentation based on composter. As what Tamil said earlier, composter consists of sewage sludge, oil sludge, and also of certain leftover foods. Again, this is a case study by taking 6 different ratio of composter, ranging from 1 to 6, within a period of 9 weeks, so that we can determine how much of oil and grease is being removed through percentage value of it, weight percentage. So as you can see from this graph, that composter 4 has the maximum percentage removal, weak 9 at the highest ratio, which is indicated by the triangle, by the X mark. And in contrast to that, composter 3, which is indicated by the triangle mark over here, it ends early. It has the lowest percentage and it ends at week 8. Moving on. This table actually is an average value. Based on the graph earlier, we took an average value percentage to calculate this data, and again we found that composter 4 has the highest percentage of oil and grease removal, which proves that there's a large amount of oil and grease being removed. And why is this so? This is due to the fact that the rate of biodegradation is very high due to the ample amount of sewage lines being extracted out from the water line. At the same time as well, composter 2 showed the lowest percentage removal of oil and grease, having a percentage of 20.33. This again shows that there's a small amount of oil and grease being removed. Why is this again so? This is because that the biodegradation rate is very low or little or there's none at all due to having no amount of sewage that is very present in our treatment line. Next, I'll be passing on to Siam for the conclusion.
Okay, so as to conclude all of this, a plan incorporated with a SCADA embedded PLC will be very expensive. But if such expenses are met, it will help facilitate easier monitoring and tracking of system processes and parameter variables. But it's not only that, it will help automated control as well as direct control. Another advantage would be that during faulty runs and erroneous operation, it will provide alert system as well as warning, and also will provide ample opportunities to aid in the recovery of the system. But all these things comes at a price, because running such a system will require technical expertise if some malfunction occurs to the system. If all of these proves to be a bit too much, an alternative option would be using microbial degradation. That is all. Thank you.